Yeah. Good afternoon, students. Hello, good afternoon. So, students, good afternoon once again. Welcome to today's class. So, in the previous class, we discussed about factor studies stages, different stages that are involved. That includes even data collection and data analysis. Now, we go for the next one, usability engineering methodology. This usability engineering methodology is, we can say that it's a part of human factor research studies, or you can also say that it's a subclass of human factors research. So, why this usability engineering methodology is included here means, so in this method or this particular methodology is very much helpful for us to determine the ease of use of a given product. For example, let us say a product has been developed and assume that the product is already available with us. So you can imagine a mobile watch, later you can imagine any other pen, whatever it may be. So when that product is, whether that given product is easy to use or not, and is more important. Okay, then consequences separate. Use అయిన తర్వాత consequence ఎలా అంటే that is we are not worrying about, but we are worrying about how much ease it is for the human beings to use that product, that particular product. So this usability engineering methodology is a subclass of human factors research to determine how the ease of use of a given product. Okay, it differs from general purpose VR human factor studies, which are more theoretical in nature. So whatever the studies that we have seen so far, that is the previous class, that is different stages involved in human factor studies. Compared to that, this is a little bit difference, more what we can say, it is a little bit different to that of what we have seen earlier with the different stages. So this usability engineering is aimed at always at product oriented only. ముందు క్లాస్లో హ్యూమన్ ఫ్యాక్టర్ స్టడీ స్టేజెస్ చదువుకున్నాము, అది జనరల్ ఆస్పెక్ట్లో ఉంది, and that too they are all theoretical in nature. Now this subclass of human factors research, that is usability engineering methodology, is always aiming at product oriented. It is always iterative in nature and part of the product development cycle. This methodology, as again I'm just repeating, it is always aimed at product oriented, iterative in nature and part of the product development cycle. There are no clear standards mentioned here because this is an area of active research. This particular usable engineering methodology in virtual reality, it doesn't have any clear standards. అంటే ఇది ఒక పర్టికులర్ మోడల్ ఇట్లానే డెవలప్ చేయాలి, ఈ పర్టికులర్ మోడల్ ఇట్లానే ఇదే డైరెక్షన్ లోనే ఇదే మోడల్లో డెవలప్ చేయాలి అన్నది అట్లేం లేదు. క్లియర్, there are no standards, there are no clear standards that are mentioned in this particular methodology because it's an active research and it is still going on. This particular usability engineering methodology involves 4 stages or consists of 4 stages. First stage, user task analysis. Second stage, expert guidelines based evaluation. Third stage, formative usability evaluation. Nothing but simply formative evaluation. And the fourth stage, last one, is summative evaluation. So, Mr. Hicks and Gabbard in the year 2002, they developed this particular methodology. So 4 stages involved are what? User task analysis, expert guidelines, user task analysis, expert guidelines based evaluation, formative usability evaluation, summative evaluation. As an example, let us consider a C Dragon software or a game, or some sort of what we can say. United States, they developed this particular model in virtual reality, and that too in a naval research laboratory. This model involves what? Military command and control application example. So, to explain this usability engineering methodology, this Sea Dragon example will help us to understand in a better way. Let us see what it is. First stage. What is the first stage here? User task analysis. So what is there involved in this user task analysis? That is the first stage. Here, we need to define the task, and also we have to list out the user's actions and systems resources needed to it. అంటే ఇక్కడ టాస్క్ అనేది డిఫైన్ చేయాలి, అండ్ అట్ ద సేమ్ టైమ్ we have to prepare the user's actions list and what are the system resources that are required. అంటే ఒక టాస్క్ ఏదైనా చేసేటప్పుడు దాన్ని అనలైజ్ చేసుకోవాలంటే దీస్ ఆర్ ద థింగ్స్. దట్ మీన్స్ యూ హ్యావ్ టు డిఫైన్ ద టాస్క్ అండ్ లిస్ట్ యూజర్స్ యాక్షన్స్ అండ్ సిస్టమ్ రిసోర్సెస్ నీడెడ్ టు ఇట్. Is it clear? So in this user task analysis, what you have to do again, you have to identify the interrelationships and user information flow during the task. So once if you define the task and the list users actions, then you need to identify the relationships and user information flow during the task. Until during the particular entire task, you need to see that the information is to be flown, and at the same time interdependencies, interrelationships, nothing but dependencies and order sequences. As an example, first let us say, in order to run a college, you can take the college example where principal is the head and faculty are the subunits. Is it clear? Technical staff are also subunit. Is it clear? So what are the actions here now? Task is what? Administering an engineering college. Then list users actions. So if you want to administer an engineering college, who are the persons that are required? Right from principal, then heads of the institution, then teaching faculty and non-teaching faculty. Like this, we are going to list out the users actions. Is it clear? Once if we list out, then what you have to do, you have to identify the interrelationships. And who are dependent on who are independent. ఒక గ్రూప్లో ఒక 20 మెంబర్స్ ఉన్నారనుకున్నాం. ఆ 20 మెంబర్స్లో కూడా కొంతమంది వేరే వాళ్ళ మీద డిపెండ్ అవ్వచ్చు, ఇంకొంతమంది వేరే వాళ్ళ మీద డిపెండ్ అవ్వచ్చు. అలానే కాలేజ్ అడ్మినిస్ట్రేషన్ ఎగ్జాంపుల్ తీసుకుంటే వీ కెన్ సే దట్ వాట్ వీ సే ద టీచర్స్ ఆర్ ద ఫ్యాకల్టీ or dependent are always waiting for the instructions given by the HOD, and HOD will be again in turn will be waiting for instructions given by the principal. Okay, there is a flow here. Order of sequence is there: principal to HOD, HODs to faculty, like that. So you can imagine. So even this type of identifying the relationship is also more important, and we have to see that user information flow during the task. Poor task analysis. If the task analysis is very much poor, then what will happen? It will cause bad product design. So what is the task now in an engineering college? The teacher has to deliver the things as per the procedure laid down. Who laid down that procedure? Nothing but the hierarchies. So maybe principal or maybe HOD or whoever maybe. If the methodology of delivery, అంటే ఇప్పుడు టీచింగ్ లో ఎగ్జాంపుల్ తీసుకుంటే టీచింగ్ మెథడాలజీ డెలివరీ అనేది వెరీ బ్యాడ్ గా ఉందనుకోండి, వాట్ అబౌట్ ద ఎంటైర్ నౌ? సో ఒక బ్యాచ్ అట్లా ఉండొచ్చు, బట్ రెండో బ్యాచ్ మూడో బ్యాచ్ కూడా అట్లే రెగ్యులర్ గా బ్యాడ్ గా ఉంది అనుకోండి మన టీచింగ్ ఏదైనా పర్టికులర్ సబ్జెక్ట్. ఆఫ్టర్ సమ్ టైమ్ వాట్ హ్యాపెన్స్? Student gets frustrated if the teaching is very bad, and if it still continues, sometimes you need to go for fighting with the management like that. When the teaching delivery is not designed properly, then it goes wrong, and we can say that it always creates frequent cause of bad product design. So if the task analysis itself is very poor, then it gives us some sort of what we can say bad product design. So now here, for this particular example, Sea Dragon example, this is one example considered for this one. For this particular example, the task is in 3D navigation and object selection and manipulation. 3D navigation means, let us say that this vehicle has to move from here to here, or even one more object has to move to this particular place. So in a 3D world, the task is to be what? Identifying the navigation. So 3D navigation is the task and object selection is the task. And also implementation. So if we give the task to the Sea Dragon in such a way that 3D navigation, object selection and manipulation are involved, is it clear? Then we can apply this particular user task analysis. Is it clear? It differs from classical 2D maps and symbols. If you see here, this particular map is appears to be that they are on 3D maps, but actually 2D maps are also available. I hope you understand. The first stage of usability engineering methodology is user task analysis. So here the task is what? Or here in this particular first stage, you need to identify the task, and also you need to list out the different users' actions that are involved in this particular particular start. Once if you have the task definition and users actions, then we can go for identifying the interrelationships. That is, who is dependent on other, who is independent. Like that, we need to identify the interrelationship. And also, user information flow is to be identified during the task. If the task analysis itself is poor, then frequent cause of bad product design will occur. As an example, to explain this usability engineering methodology, the Sea Dragon example is considered. Where for this particular example, the task is what? 3D navigation and object selection and manipulation. So this differs from 2D maps and symbols. I hope you understand. This is what happens in the case of first stage. Second stage is what? Second stage, sometimes we also call it as heuristic evaluation, or we can say that expert guidelines based evaluation or expert system guideline evaluation. Like that. So second stage aims at identifying potential usability problems early in the design cycle. Sometimes we call this particular stage as heuristic evaluation. So after the completion of the task analysis, the next stage is what? Identifying potential usability problems near you in the design cycle. So that means this particular second stage is also called as heuristic evaluation. So this particular evaluation aims at potential usability, the problems, potential usability problems early in the design cycle. So what actually in this stage involved means, so we are going to take a comparison of users' action done by the experts. Let us say a pen and pencil or paper and pencil comparison of users' actions done by experts, first alone and then as a group to determine the consensus. That means in this particular case, in order to identify the potential usability problems, pencil and paper comparison of users' actions done by the experts is to be done first and then as a group. అంటే ఇండివిజువల్గా declare users యాక్షన్ బేస్ చేసుకొని పెన్సిల్ అండ్ పేపర్ కంపారిజన్ స్టేట్ చేస్తాం. After that, we need to do the same thing even for the group. As an example here for dragon, sea dragon example తీసుకున్నాం కదా. This particular sea dragon example, if you take ease of navigation was identified as a critical issue. Ease of navigation అంటే navigation ఎలా ఉంది, that was identified as a critical issue. Experts identified problems with the system responsiveness when using a flight stick. The using a flight stick, we call it as van with buttons. So for this particular sea dragon example, ease of navigation was identified as a critical issue. Experts identified problems with the system responsiveness when using a flight stick. And then when flight stick is employed, then in that case, the system responsiveness resulted in identifying some problems when using flight stick and performing exocentric navigation. Here, the user was outside of the environment looking in. Next, the third stage. Please remember, second stage is identifying potential usability problems early in the design cycle. So for that, a pencil and paper comparison of users' actions are done by the experts is to be recorded first alone and then as a group. For the example that we have seen, that is sea dragon, here ease of navigation was identified as a critical issue when using a flight stick, that is van with buttons, and performing exocentric navigation. Exocentric means the user was outside the environment. Next, the third stage is what? Formative evaluation or formative usability evaluation. So the third stage is what? An iterative process is to be designed where the representative users are asked to perform the task. So the third stage involves iterative process, nothing but formative evaluation, where the representative users are asked to perform the task. During task performance, various variables are measured, and such as task completion time and error rates. So in this particular task, that is stage, various variables are measured, which includes what? Task completion time and error rates. and these are used to do product redesign, and the process is repeated. Okay, now for this Sea Dragon example, formative evaluation had two stages. During the first stage, the best interface was selected between three candidates. Example, the one candidate is using pinch glove, one candidate is using voice recognition, and the third one WAND. Voice recognition was ineffective, and pinch glove produced time delays when transforming to another user. Thus, WAND was selected. So during this formative evaluation, this Sea Dragon evaluation had two stages. First stage, the best interface was selected between three candidates. That is pinch glove, voice recognition, and WAND. And voice recognition was ineffective, and pinch glove produced time delays when transferring to another user. This WAND was selected. The second stage of Dragon formative evaluation used a large number of subjects that had to navigate while errors were recorded. So second stage of Dragon formative evaluation used a large number of subjects that had to navigate while errors were recorded. A large effort was made in mapping the WAN button to functions. Pan and zoom were mapped to the WAN trigger. Pitch and hidden to the left button, while exocentric rotate and zoom were mapped to the right button. So like that it is considered. The second stage of Dragon formative, if you see this particular example, military command and control application example is Sea Dragon. The Sea Dragon is just to explain this particular usability engineering methodology. And the last stage is what? Summative evaluation, which is done at the end of the product development cycle. It is done to statistically compare the new product with other products to determine which is better. That means already you are going to develop many products. Take one product and compare their performance with other products. So that gives you summative evaluation, which is done at the end of product development cycle. It is done statistically, compare the new product with other products to determine which is better. The selection among several candidates is done based on field trials and expert reviews. The selection is done in such a way that field trials and expert reviews play an important role. The summative evaluation of Dragon involved the study of 4 parameters. The conclusion of this particular usability engineering methodology, that is summative evaluation of this particular Dragon example, involved 4 parameters. One is navigation metaphor. Second one, gesture mapping. Third one, display device. And fourth one is graphics mode. Navigation metaphor, gesture mapping, display device, and graphics mode are the 4 parameters that are considered during this example. For this particular example, 32 subjects were taken and divided into different groups, that is 4 groups. Each group was assigned a different combination of conditions as shown here. So between subjects, within subjects, see here, between subjects is this one, within subject is this one. So different groups were considered. 1 to 4 as one group, subjects 5 to 8 as one group, like similarly 9 to 12 as one group, 13 to 16 as one group, like that. Each group was assigned a different combination of conditions. See here, when the steering wheel is on, is it clear? You can observe within subject computer platform, grotto, wall, workbench, desktop. Between subjects, you can have variation between stereo viewing, control movement, and frame of reference. So this particular example results showed that users performed fastest on a desktop monitor and they are slowest on the workbench. Egocentric navigation was fastest in monoscopic graphics. Exocentric navigation was fastest in stereo graphics. So fastest in stereo graphics is what? Exocentric navigation. Rate control was fastest in monoscopic graphics and position was fastest for stereo graphics. So the results of this usability engineering methodology, we showed that the users performed fastest on desktop monitor and the users were slowest on the workbench. That means when the users are using workbench, they are unable to do the work on this workbench. Egocentric navigation was fastest in monoscopic graphics. Exocentric navigation was fastest in stereo graphics. Also, the rate control was fastest in monoscopic graphics and position was fastest for stereo graphics. So these are the conclusions for usability engineering methodology. Egocentric, exocentric. Rate control was fastest in monoscopic graphics and position was fastest for stereo graphics. So with this, the usability engineering methodology is completed. I once again repeat what is usability engineering methodology. This methodology is a subpart of what? Human factors research, where this is oriented always in product oriented, iterative in nature, and part of the product development cycle. There are no clear standards in this usability engineering methodology. The methodology consists of 4 stages here, that is usability engineering methodology. The first stage is user task analysis. Second stage, expert guidelines based evaluation. Third stage, formative usability evaluation. Fourth one, summative evaluation. Fourth one is what? Summative evaluation. So C-Dragon example was considered for explaining this particular usability engineering methodology, where the C-Dragon first stage involves defining the task and users' actions and system resources. It identifies the relationships and user information flow during the task. Also, whether the task analysis is done perfectly or not. So, poor task analysis is the frequent cause of bad product design. For the C-Dragon, the task is what? 3D navigation and selection and manipulation. So this particular 3D navigation differs from classical 2D maps and symbols. Second stage, which is also called as heuristic evaluation, aims at identifying potential usability problems early in the design cycle. Pencil and paper comparison of users' action done by experts, first alone and then as a group, is to be done. And the example that is considered is C-Dragon. For this C-Dragon, ease of navigation was identified as a critical issue. And the next stage is what? Iterative process, where the representative users are asked to perform the task. So third stage involves iterative process, where representative users are asked to perform the task. So during this task performance, various variables are measured, such as task completion time and error rates. These are used to do product redesign, and the process is repeated. So this C Dragon example, for formative evaluation, two stages are considered. During the first stage, the best interface was selected between the three candidates. Interface here, pinch glove, voice recognition, and WAND. Voice recognition was ineffective, and pinch glove product time delays when transferring to another user. Thus, WAND was selected for this formative usability evaluation. And coming to the last stage is what? Summative evaluation, which is done at the end of product life cycle. It is always done to statistically compare the new product with other products to determine which is better. The selection among several candidates is done based on field trials and expert reviews. So this particular summative evaluation of 3D, the Dragon example which you have seen, involves the study of four parameters: navigation member, gesture mapping, display, device, and graphics mode. These are the four parameters that are considered by Dragon to be as summative, to deliver summative evaluation. So this table gives you explains the summative evaluation here, which includes 32 subjects were considered into four groups. Four groups were divided. For each group, one method is given. Grotto method for first group, Paul method second group, workbench third group, and fourth group is desktop group. Like that, each group was assigned a different combination of conditions. The result of these studies show that the users performed fastest on desktop monitor and were slowest on the workbench. Egocentric navigation was fastest in monoscopic graph, and exocentric navigation was fastest in stereographics. Whereas the rate control was fastest in monoscopic graphics, and position was fastest for stereographics. Like this, these are the points which are resulted when usability engineering methodology is employed. With this, we stop, and we further take the next topic, that is user performance studies, in the next class. Meanwhile, I'll take attendance here, and the software is not working properly. I'll just read out the names. So, okay, 202 Bhargavi, 369, 369,
9 present, sir.
15,
6 present, sir.
17, 22.
17 present, sir.
13 present, sir.
Irma?
13. 213.
Yeah, I included. Okay, next 22 present, 23, 28, 30.
22 present, sir.
Okay, 32, 33, 36. 38, 40, 41.
41. 30 present, sir. 230.
Okay. Okay. 43, 44, 46.
43
41 present, sir. 44 present, sir.
Okay.
43
38
present.
present, sir. 238.
Okay. 47. Sorry, I'm just getting hiccups.
233 present, sir.
Okay.
238
Next.
present, sir.
Okay. 50, 53, 58. Another
228 present, sir.
Irma? 60, 67, 69,
63 present, sir.
72. Okay. 63 present.
63.
2C4 present, sir.
ఇక్కడ రాలేదు 63.
253,
Did you
sir.
join here? 53. Okay.
253, sir.
2C4 present, sir.
అక్కడ రాలేదు 75.
Sir, 269 present, sir.
276 present, sir.
Okay. 78, 81,
238 present, sir. 238.
83, 84, 94.
Sir, 84 present, sir.
94 present, sir.
83 present, sir.
99. 99.
99 present, sir.
A0. A7.
Sir, 258, sir.
A7 present, sir.
58. Okay.
99 present. A7 present, sir.
Sir, 215, sir.
Okay. Amma.
2A9, sir. Sir, 2A7.
Okay.
Sir, 299.
Sir, 2B6, sir. Present.
2B6. 2B5.
2A7, sir.
2A7. Okay.
299, sir.
2B1, sir.
Okay.
2C2 present, sir. 2A9, okay, sir. 2B41 present.
Okay.
2B7 present, sir.
2C7.
2C2 present, sir.
2B7 present.
Okay. Amma.
2B5.
Just a minute.
2B7 present, sir.
2C1, sir.
Total 50 members are there as I have noted. Okay. Thank you very much. Now I'm going to stop it.
Sir, 2B5.
Okay. Amma. Okay.
Sir,
Check.
2B7.